Hello, Matthews Gatos here. Welcome to part 2 of your AP bonus video. In this video, we're going to be talking about how to solve a system of linear equations using matrices. So let's begin with just a definition of what a matrix is. A matrix is a rectangular array, which means arrangement of numbers. We put square brackets around that array and call the whole thing a matrix. If I have more than one matrix, I call that matrices, so that's the plural word. Now the numbers inside the matrix are called elements, and those elements are arranged in rows horizontally and columns vertically. So if I want to talk about the dimensions of a matrix, I always list that as rows by columns. So here's some examples. This is a 2 by 3 matrix here. So we have 2 rows and we have 3 columns. This example right here is a 3 by 4 matrix because I have 3 rows and I have 4 columns. So whenever we deal with the dimensions, it's always rows by columns. Now, what we want to do is take our system of equations and write them in a matrix so that we can use them. So first thing I want to do is make sure that all my equations are in alphabetical order of variables. So A, B, C, or X, Y, Z. D, E, F, etc. And I always want the answer on the right-hand side of the equal sign. Any variable that is missing, we're going to write that with a 0 in front, and then we're going to place the coefficients of the variables and the answer into the matrix in the order they appear in the equation. So this is really key. I just want to be able to practice this. So if we look at this here, I have 3 equations and 3 unknowns. So I need a 3 by 4 matrix. So I'm going to first of all make sure I have them all in correct order, X, Y, Z. So the first equation is in order, X, Y, Z, and then answer. So I write the coefficients. So it's a 1, a negative 1/3, paying attention to the signs, a half, and a 1. If I look at my next equation, I'm missing an x. So this equation here, I would rewrite it as 0x plus y minus a half z equals 4. So it's all in alphabetical order, and I would write it as 0, 1, negative a half, and 4. And then the last one is missing an x and a y. So I'll write that as 0x plus 0y plus z equals negative 1. So that's how you take a system and write it in matrix form. Notice I have this dashed line. I like to have that because it separates the variables from the answers. So I will always put that there just to kind of keep everything separate. So I know this is kind of like the equal sign, okay? So that's what that dashed line represents for me. Okay, let's try this one here. So again, I have 3 equations, 3 unknowns. I want to write it in a 3 by 4 matrix. So if you look at this x, y, z, the first equation is good to go. So I have 1, negative 1, 1, and 5. My second equation here, I'm missing an x. So I'm going to write that as 0x minus 2y plus z equals 6. So this will be 0, negative 2, 1, and 6. And then my last one is missing an x, but everything else is in good order. So that will be 0, 2, negative 2, and negative 12. So that's just how we write them into matrix form. Okay, one last one. This one's all jumbled up, so we have to definitely make sure it's in the correct order. So down here, I want to go x, y, add z to both sides because it's equal to z on the other side. So I'm going to add z equal to 2, and then it's ready to go. Okay, this one here, the number needs to be on the other side. So I have x, y, z, and then add 31 to both sides. And then this one here, I'm going to add 2x so that I have 2x over here, x, y, z, and I will subtract 13 from both sides. Okay, so again, the important part here is that you have everything in alphabetical order and you record a 0 for anything that you're missing. Answer on the right-hand side of the equal sign. So I have 1, 1, 1, and 2. 6, -4, 5, and 31, 2, 2, 5, and -13. Okay, so what this kind of reminds me of is when we did long division of polynomials, and then we switched to the shortcut, which was synthetic division. So we're getting rid of our variables and just working with the numbers. So solving systems of equations by matrices kind of reminds me of synthetic division for that reason. Okay, so a special type of a matrix is called the identity matrix. And it's called an identity because anytime I multiply a comparable matrix by the identity matrix, I will get the matrix itself. So any matrix multiplied by an identity matrix gives the matrix itself. That's why it's called identity. So an identity matrix is a square matrix. In other words, the number of rows equals to the number of columns. It has ones on the main diagonal and zeros everywhere else. So here's an example of a 2 by 2 identity matrix and a 3 by 3 identity matrix. So ones on the main diagonal, zeros everywhere else. So our goal in solving using systems of equations using matrices is to take something like this, which comes from a system of equations. So system of equations goes into like this, and I want to turn it into this. And what this is it's made up of an identity matrix to the left of the equal sign and a column matrix, which is the answer. So if I was solving this system of equations, I would write it as a matrix like this. And my goal is through matrix operations, I'm going to get it into this form here. And the reason that that's a big answer or a big deal is because now I know the answer. So my first variable, which was x, equals 5. My second variable, which was y, equals 3. And my third variable, which was z, equals -2. So that is the solution. So the trick in this lesson is going to be, how do we go from this to this? How do we go in that direction? And as I already mentioned, it's through matrix row operations. So here's the things you can do to a row in a matrix. You can switch rows. You can multiply a row by a number, or you can add rows. So just like we do with systems of equations, we organized and we really illustrated what we were doing. We're going to do the same thing here. So let's say I wanted to interchange 2 rows. I'm just going to write it like this as an example. Say I wanted to switch around rows 1 and 3. I'm going to show it like that. Then let's say I wanted to multiply a row by a number. So let's say I wanted to multiply row 1 by 2, and I'm doing that and I'm putting it back onto row 1. So this says multiply 2 times row 1, put it onto row 1. The reason we have to say that is because you could in the next one add rows, like add multiples of rows or add a single row. So let's say I wanted to add row 2 and row 3, and I want to put the result onto row 2. These are the notations that we will be using. Okay, so this is the operation, and this is where the operation is going. This is the operation, and this is where we are placing that operation. Okay, so a tip for you when you're doing matrix row operations, if you can't get the identity matrix to the left of that dotted line using any of these row operations, that means the solution either does not exist or there are infinite number of solutions. I'll show you an example of each one of those in this lesson. So here are your 6 steps to success when it comes to matrices. Your very first step is to get a 1 in row 1, column 1, and then zeros below that. Your third step is going to be to get a 1 in row 2, column 2, and then get zeros above and below that 1. And then step number 5 is going to be to get a 1 in row 3, column 3, and zeros above and below that. So essentially what you are doing is you are trying to create the identity matrix to the left of the dashed line. Okay, because what we want is we want the identity matrix, and then after the dashed line is the solution, which will be a column matrix. That's our goal. Okay, let's go ahead and try this. So in my first one here, first thing I want to check is that I have them in alphabetical order. So F, G, H, and I record a 0 for anything that's missing. So F, G, H, answer. F, G, H, answer. F, G, H, answer. Okay, so what I want to do is I want to get a 1 in row 1, column 1, and zeros everywhere else. So I already have a 1 in row 1, column 1. So what I want to do is get zeros everywhere else. Okay, so here's what we're going to do. And there's multiple ways of doing this, just like we did with systems of linear equations. And we're all going to do this through eliminations. So what I'm going to do is I'm going to leave row 1 as row 1. I'm just going to leave it as row 1. 1, 1, 1, 13. And then in row 2, what I'm going to do is I am going to do negative row 1 plus row 2 onto row 2. So what I'm doing is I'm multiplying row 1 by negative 1, and then I'm adding it to row 2. So negative 1 plus 1 is 0. Negative 1 plus 0 is negative 1. Negative 1 plus negative 1 is negative 2. And negative 13 plus negative 2 is negative 15. Okay, so now I've got a 0 here, which is what I wanted. Okay, for the next one, I'm going to do 2 times row 1 and add it onto row 3. My result stays onto row 3. So 2 times 1 is 2 plus negative 2 is 0. 2 times 1 is 2 plus 1 is 3. 2 times 1 is 2 plus 0 is 2. 2 times 13 is 26 plus 3 is 29. Okay, and now I have a 0 here. So next step is going to be to get a 1 in row 2, column 2. So I want to change this into a 1. So I'm just going to go through and repeat this process again. Oh, wrong one. Let me try that again. There we go. Okay, so I want a positive 1 in that row. So what I'm going to do is multiply row 2 by negative 2. Negative 1, sorry. Multiply row 2 by negative 1. So 0 times negative 1 is 0. Negative 1 times negative 1 is positive 1. Negative 1 times negative 2 is 2. Negative 1 times negative 15 is positive 15. So now row 2 is good. I want zeros everywhere else. So when I go back up here, I am going to add row 1 and row 2 and place the result in row 1 because I noticed that these here are opposites. So 1 plus 0 is 1. Negative 1 plus negative 1 is 0. 1 plus negative 2 is negative 1. And 13 plus negative 15 is negative 2. Okay, so see what I'm trying to do? I'm trying to build the identity matrix on the left-hand side of that dashed line. Okay, so for the next one, I am going to try and get rid of this 3 here. So I'm going to multiply row 2 by 3 and add it onto row 3. So 3 times row 2. So 3 times 0 is 0, plus 0 is 0. 3 times negative 1 is negative 3, plus 3 is 0. 3 times negative 2 is negative 6, plus 2 is negative 4. And 3 times negative 5 is negative 45. And I'm going to add that on to 29, and I get negative 16. Okay, we're getting there. Next step is going to be to get a 1 in row 3, column 3. So I'm going to take this down here, and we're going to keep on going. So I want to get a 1 right here. So I'm going to multiply row 3 by negative 1 over 4 onto row 3. So 0 times negative a quarter, 0. 0 times negative a quarter, 0. Negative 4 times negative a quarter, 1. Negative a quarter times negative 16, positive 4. Okay, now that I've got that, I want to get zeros everywhere else. So what I am going to do, let's think here, is I am going to, for row 2, I am going to multiply row 1 by -2 and add it on to row 2. So -2, no, that's not going to work. Okay, what I'm going to do is I'm just going to leave this for right now. Let's leave this here because we can't do anything yet. And let's write it out. 1, 0, -1, -2, 0, 1, 2, and 15. Now I can see what I need to do. Okay, so what I'm going to do now, here we go, is I want to get a 0 right here, and I want to get a 0 right here. So I am going to, on row 1, I'm going to take row 1 and add it to row 3, putting it onto row 1. So 1 plus 0 is 1. 0 plus 0 is 0. -1 plus 1 is 0. -2 plus 4 is 2. Okay, that's good. Now for row 2, I'm going to multiply -2 by row 3 and add it onto row 2. So -2 times 0 plus 0 is 0. -2 times 0 is 0 plus 1 is 1. -2 times 1 is -2 plus 2 is 0. -2 times 4 is -8 plus 15 is 7. And then leave row 3 as it is. And now we have the identity matrix here. And we have the solution here. So all I have left to do is state my solution as a point. Okay, so stating my solution as a point, the solution is x. No, did we start with x, y, z's? We started with f, g, h's. So let's make sure we're using the correct variable. So f, g, and h is going to equal to the point 2, 7, and 4. So that will be my entire solution. Now some of these questions are going to take quite a bit of steps, but those are the steps that you're going to be following. Okay, so you want to have a 1, 1, and 1 on the main diagonals, zeros everywhere else, and this would be your answer. Now the most important part of solving any equation is of course the check. So let's check if 2, 7, 4 is the correct solution. So what I'm going to do is I put it into each one of my original equations. You can see I've worked every single one out and they're all equal. So therefore I know the solution is 2, 7, 4. Okay, let's try another one. So for this one here, let's put it in our matrix form, just doing a quick check, x, y, z for all of them, yes. And then put the numbers in here. Okay, and now we're ready to solve. So right away I noticed that row 2 has a 1. So instead of doing a whole bunch of work, all I'm going to do is interchange row 2 and row 1 together. So let's try that. So the first thing I'm going to do is take row 1 and switch it with row 2. So row 1, and I'm going to put that into row 1. So this will become row 1, and this will become row 2. And then row 3 stayed the same. Okay, so now I'm ready to go. I have a 1 in the top corner. So what I want to do is make zeros everywhere else below. So I'm going to multiply, row 1 is going to stay as row 1. I'm going to multiply row 1 by -3 and add it on to row 2. So -3 times 1 is -3 plus 3 is 0. -3 times 3 is -9 plus -2 is -11. -3 times 1 is -3 plus 1 is -2. -3 times -4 is 12 plus 12 is 24. And then do the same thing here. So -2 times row 1 plus row 3 onto row 3. So -2 times 1 is -2 plus 2 is 0. -2 times 3 is -6 plus 2 is -4. -2 times 1 is -2 plus -4 is -6. And -2 times -4 is +8 plus 6 is 14. Okay, so now we've got a 1 there. We want to have a 1 here. So you have a couple of choices. You can switch around these rows here because this is divisible by 2, or you can just divide everything by -11. It really is a matter of preference what you want to do. So let's leave, obviously, row 1 as 1. 1, 3, 1, and -4. And then we'll just divide everything by -11. We'll just leave it as it is and divide everything by -11. So -1 over 11 times row 2 onto row 2 to make this into 1. So I'm going to do -11 times -1 over 11 is +1. And then I'll do -2 times -1 over 11, and I'm going to keep that as a fraction, which is 2 over 11. And then I'm going to do -1 over 11 multiplied by 24, which is just -24 over 11. Okay, and then this one here will stay like that. Okay, so sometimes we're going to end up with fractions, but hopefully as we go along, those fractions will eliminate themselves. So I have a 1 here, now I want zeros everywhere else. So in row 1, I'm going to do -3 times row 2, add it on to row 1, and put it into row 1. So -3 times 0 is 0 plus 1 is 1. -3 times 1 is -3 plus 3 is 0. And then I'm going to do -3 times 2 over 11 plus 1, and that's 5 over 11. And then -3 times -24 over 11, and add that on to -4, and that is 28 over 11. Okay, I'm going to leave row 2 as itself, 2 over 11, -24 over 11. And then I'm going to do 4 times row 2, add on to row 3, and put it into row 3. So 4 times 0 is 0 plus 0 is 0. 4 times 1 is 4 plus -4 is 0. 4 times 2 over 11 plus -6 is -58 over 11. And then 4 times -24 over 11 plus 14 is 58 over 11. Okay, so let's go into our next step. Our next step is going to be to get a 1 down in row 3, column 3. So I'm going to just leave rows 1 and 2 alone for right now. So leave row 1 and row 2 as they are. Oops. 1, 2 over 11, and -24 over 11. Okay, and then what I'm going to do is I am going to multiply row 3 by the reciprocal, which is -11 over 58, and then put that onto row 3. Okay, so -11 over 58 times 0 is 0. -11 over 58 times 0 is 0. -11 over 58 is +1. And -11 over 58 times 58 over 1 is -1. Okay, so now that I have a 1 there, I just have to get zeros everywhere else. So let's do this again. So I will leave row 3 alone. And let's hope we get rid of some of these fractions. Okay, so in row number 1, to get rid of this 5 over 11, I am going to multiply by -5 over 11 to row 3 and add it on to row 1, keeping it on row 1. So to row 3, -5 over 11 times 0 is 0 plus 1 is 1. -5 over 11 times 0 is 0 plus 0 is 0. -5 over 11 times 1 is -5 over 11 plus 5 over 11 is 0. Okay, and then I'm going to do -1 times -5 over 11, and then add that on to 28 over 11, and you get 3. Our fractions are gone. Okay, for row number 2, I want to get rid of this 2 over 11, so I'm going to multiply negative 2 over 11 by row 3, add that on to row 2, and keep it on row 2. So negative 2 over 11 times 0 is 0, plus 0 is 0. Negative 2 over 11 times 0 is 0, plus 1 is 1. Negative 2 over 11 times 1 is negative 2 over 11, plus 2 over 11 is 0. And then I do negative 1 times negative 2 over 11, and I add that on to negative 24 over 11, and I get negative 2. So our fractions are all gone. And sometimes you'll have fractions, and that's okay. So what this means is, over here I have the identity matrix. This is the identity matrix, and this is your solution. So what that tells me is we had x, y, and z. That's equal to 3, negative 2, and negative 1. Again, I do want to check that. So I check that in each of my equations, okay? And show all your steps to show that they are equal. So it balances each of those, so I know that this is the solution. Okay, let's try this one here. So again, x, y, z, they are all there. They're all in order. That's good. So we can start placing them in. So 5, negative 2, 1, and 3, 4, negative 4, negative 8, and 2, negative 1, 1, 2, and negative 3. Anytime you have a 1, put that right away into row 1. So what I'm going to do is I am going to interchange row 1 and row 3, putting it onto row 1. So this will be my new row 1. This will be my new row 3. Okay, and then I'll keep this here as is. Okay, so now that I have a negative 1 there, I'm close to having a 1. All I have to do is multiply row 1 by negative 1. So negative row 1 onto row 1. So just switching the signs of everything like that. Okay, so to get rid of the 4, I'm going to multiply row 1 by 4 and add it on, oops, row 1, not row 4. Okay, let me try that again. So 4 times row 1 added on to, okay, or we'll just erase the whole thing, sure, plus row 2 onto row 2. So 4 times negative 1 is negative 4, plus 4 is 0. 4 times 1 is 4, plus negative 4 is 0. 4 times 2 is 8, plus negative 8 is 0. Uh-oh. 4 times negative 3 is negative 12, plus 2. Negative 12 plus 2 is negative 10. Okay. Now I'm going to do 5 times row 1, add on to row 3, keep it on row 3. Let's see what we end up getting. So 5 times row 1 is negative 5, plus 5 is 0. 5 times 1 is 5, plus negative 2 is 3. 5 times 2 is 10, plus 1 is 11. And 5 times negative 3 is negative 15, plus 3 is negative 12. Okay, so if you look at this row here, we've gotten rid of all of our x, y, and z values. Essentially what this row is saying is that there are 0 x's plus 0 y's plus 0 z's equal to negative 10. So what do you guys think about that solution? So you can see that 0x plus 0y plus 0z equal to negative 10. That is not true. You cannot have 0 equal to negative 10. So since we can say that 0 cannot equal to negative 10, that statement is always false. We would therefore say there is no solution to this system. So since there is no solution to this system, that means that there is no point of intersection for all of these. We cannot go any further. Okay, let's try this next one. In this next example here, again, you want to just check to see if you have them all there, x, y, z in alphabetical order, which I do. So let's just write them all in. So x, y, z, answer. X, Y, Z, answer. X, Y, Z, and then answer. Okay, so for this one here, I already have a 1 in row 1, so that's good. We're off to a good start. So we'll leave row 1 as row 1. And then I'm going to get rid of this 4 by multiplying row 1 by 4 and adding it on to row 2. So 4 times 1 is 4, negative 4. I'm going to multiply it by, let's try that again. Negative 4 times 1 is negative 4, plus 4 is 0. Negative 4 times negative 1 is positive 4, plus negative 4 is 0. Negative 4 times negative 2 is positive 8, plus negative 1 is 7. And negative 4 times positive 4 is negative 16, plus 2 is negative 14. Okay, let's do 2 times row 1, and we'll add that on to row 3. Okay, so 2 times 1 is 2, plus negative 2 is 0. 2 times negative 1 is negative 2, plus 2 is 0. 2 times negative 2 is negative 4, plus 4 is 0. 2 times 4 is 8, plus negative 8 is 0. We have a row of zeros. So what this means is that 0x plus 0y plus 0z equals 0. In other words, 0 equals 0. So since I have 0 equals to 0, that is always true. So since it's always true, that means that there are infinite solutions. So equations number 1 and equation number 2 are essentially the same equation. Okay, so that's the end of the video. I've given you 4 different examples, 2 where we had a point of intersection and 1 where we didn't, and 1 where we had infinite solutions. So hopefully this video helped. Matrices are always fun to do. I like this little joke. Lately, I've been feeling like nothing inside. And then the doctor says, I can definitely identify, because that is the identity matrix, with how you are feeling. So I hope that this video helped you guys. I know it was a little bit on the longer side, but you guys can go ahead and do these 4 examples for your assignment for AP Bonus 2. So again, I hope this helped, and I look forward to seeing you for the next one.